A CNC milling machine is not defined by one single best component. Real machining performance comes from how well the vital parts work together as one complete system. Each part has its own function, but only when they operate in balance can the machine achieve stable accuracy, high efficiency, and reliable production. During machining, everything begins with the CNC controller. The controller acts as the command center, reading the machining program and sending instructions that coordinate axis movement, spindle rotation, feed rate, and tool change actions. It does not physically move the machine, but it directs every motion and ensures that all systems respond at the correct time and in the correct sequence. Once the controller sends instructions, the motion system executes them. Ball screws and linear guideways convert those electronic commands into smooth and accurate mechanical movement. They control the positioning of the X, Y, and Z axes, ensuring that the tool moves precisely along the programmed path. Without stable and precise motion components, even the most advanced controller cannot guarantee repeatable accuracy. Supporting this motion system is the machine frame and bed. These structural components carry the full cutting load and resist deformation under force. During heavy milling or long machining cycles, cutting forces and vibration constantly act on the structure. A rigid frame absorbs these forces, maintains geometric alignment, and prevents distortion that would otherwise reduce part accuracy. The spindle then performs the actual cutting work. It rotates the tool at controlled speed and torque, while maintaining concentricity and stability. Spindle performance directly affects surface finish, tool life, and cutting consistency. Even if positioning is accurate, an unstable spindle can introduce vibration, poor surface quality, and inconsistent machining results. The tool magazine and automatic tool changer system support automation and workflow continuity. They store multiple tools and exchange them quickly according to the CNC program. Instead of stopping the machine for manual tool changes, the ATC allows uninterrupted machining, improving efficiency and reducing downtime. True CNC performance depends on coordination between mechanical rigidity, motion accuracy, spindle stability, and control automation. If one system is weak, the entire machine's performance is affected. When these parts are properly matched and designed to function as an integrated system, the machine delivers its best results. These components are critical because they directly determine machining accuracy. The frame maintains rigidity to prevent deformation, the guideways and ball screws ensure precise positioning, and the controller synchronizes motion for consistent execution. If any of these systems lose stability or precision, holding tight tolerances becomes difficult, especially during long or high-precision machining operations. Surface quality also depends heavily on system coordination. A stable spindle reduces vibration, smooth guideway motion ensures steady feed, and a rigid structure suppresses chatter. When these elements work together correctly, the machine produces cleaner finishes with fewer tool marks and less variation. Reliability and lifespan are equally influenced by component quality. Strong structural parts reduce long-term misalignment. Durable motion components maintain positioning accuracy over time, and a reliable control system minimizes unexpected errors. A stable tool changer reduces the risk of interruption during automated production. Over time, better component integration means fewer breakdowns and more consistent operation. Productivity is not only about higher feed rates or spindle speeds. It depends on keeping the machine running smoothly with minimal downtime. A reliable spindle supports efficient cutting, an accurate motion system reduces scrap and rework, and a stable ATC shortens cycle time. When all systems remain balanced and coordinated, the machine can operate continuously with predictable output. In short, a CNC milling machine performs at its highest level only when its vital parts function together as one unified system. Accuracy, surface quality, reliability, and productivity all depend on this integration. If you're not following now, you may not find this explanation again.